This is the third video for March 28th, March 29th. We're graphing and transforming exponential functions. Let's start by looking at what transformations would happen to this function. If you look at this function here, what's going to happen is, hopefully based on what we did in problems 1 and 2, if you haven't watched that video, please do go ahead and do that before watching this one. But hopefully we can see that because we're adding 3 outside the function, here we will, I'm going to write this down here, we're going to shift up 3 units due to this plus 3. But in class, what we talked about is a negative x. Our x is negative. What's going to happen there? Well, in this case here, we multiplied our parent function by a negative value. And because we multiplied our parent function by a negative value, we said we were going to reflect across the x-axis. So that's why this shape occurred. Here, if our x is negative, if we're multiplying our x value by a negative, then what's happening, it's actually going to reflect across the y-axis. So anytime, I'm going to write this down, I recommend you do the same. X is being multiplied by a negative value. Then we reflect across the y-axis. That is a key thing. If you need to pause it so you can write this down, that's fine. Please do so. But that is a key thing with these functions. I gave an explanation in class. I don't have the space to do that in here. If you want the explanation on why that's the case, I can give it to you. But it is going to reflect across the y-axis. So when we graph this function, 1, 2, 3, 4, 5. We can choose our parent function to either be 5 to the x. If we choose it to be that, then we need to reflect and shift it up 3 units. Or we can just choose our parent function to be 5 to the negative x and understand what's happening. For this case, let's say the parent function is f of x equals 5 to the x. So now, if it's 5 to the x, we know a couple key points with that parent function. First, we know if we plug in 0, the value is going to be 1, so our parent function goes through 0, 1. We also know if we plug in positive 1, 5 to the 1 is just 5, so 1 comma 5. And so our parent function behaves like this. We still have a horizontal asymptote. And it's going to go something like that. Now, I would always recommend reflecting first. Here, if we reflect across the y-axis, well here, if I'm at this point 1 comma 5, if I reflect across the y-axis, it's going to be a negative 1 comma 5. So that point comes here. This point here is 0, 1. Well, it's on the y-axis, so when we reflect, it's going to stay. So our reflected function looks something like this. I'm going to do like a longer dotted line. Our asymptote didn't change. So we graphed our parent function with the little dotted line. We reflected with the bigger dotted line. Now we just need to shift it up 3 units. So if we shift this point up 3 units, 1, 2, 3, then we can do that. It's going to do this here. We also shift our asymptote up 3 units, so our asymptote happens at y equals 3. That's one of your key features. And so our function looks something like this. And we can talk about domain, range, interval, end behavior, and the asymptotes of that function. I'm going to let you do that a little bit on your own. Well, let's go ahead and do that. Here, if we say, as we move forever in the right-hand direction, we say that x is going towards infinity. If we're going in the right-hand direction, as x is going towards infinity, this function is going to approach but never touch our asymptote. So our function here is actually going to approach the value 3. Similar thing, if we go forever in the left-hand direction, then we say x is going towards a negative infinity on our x-axis. And that's a fancy way of saying if we move to the left, if we go to the left along this curve, this function is going to go up. It's going to continue to go up. So we say our function f of x is approaching infinity. We say a horizontal asymptote, that got moved up to y equals 3. So our horizontal asymptote is at y equals 3. Last two things, our domain hasn't changed. It still goes forever in both directions, but our range did. So to think about the range, we think about the lowest, what it goes low, like what's the lowest value it goes to, what does it not go below? And this function does not go below 3. Here it's going to table out, it's going to get approached but never touch 3. So it will never go below 3. And it's parentheses because it doesn't touch to infinity.
Team leaders and academy principals, our meeting will start in 1 minute in the presentation room. Thanks.
Gotta love those announcements. So that's what's happening with that function. If you have questions about that, please let me know. Please let me know. Ask me in class, out of class, all that stuff. Remind, the normal stuff. I do want to talk about the transformation here, and then I'm going to let you try it on your own based off of what we did in number 2 and 3. Here, it seems like what we do know it's going to, because of the negative on the x, well, I can write it up here. How about that? It will reflect, because x is being multiplied by a negative, reflect across the y-axis. So we do know that is going to happen. And it looks like it's going to move to the left too, but it's actually not. And here's why. Anytime x is being multiplied by a value, anytime that's the case, what we really need to do here is get the x to become positive. So in order to do that, we're going to say I'm going to make x positive, which means I'm going to take the negative outside of the parentheses. If I take the negative outside the parentheses, I also have to take the negative away from here, which makes this a minus 2. If you want to think about this, if I distributed the minus sign here, that would be negative x, but 2 negatives make that a positive. So it will reflect across the y-axis still, but it will also shift to the right 2 times due to that minus 2 inside of our function. And I encourage you to try to graph that on your own, reflect across the y-axis like we did here with our base being e, and then also shift it to the right twice to get your new function. If you have questions about this, please ask me in class, out of class, Remind app, email, website, all of those options. And hopefully I can help you out on this content.